Okay, here we want to look at a process called partial fractions or partial fraction decompositions. The reason why we use partial fractions is that we have an integral that can't be evaluated using our traditional methods. So we have to break the problem down in order to evaluate our integral. That's why it's also called partial fraction decomposition. So here we have the integral of 3x plus 2 divided by x squared plus 2x. So what we do in this case, we want to rewrite this. When we factor that denominator, it's going to be a over x plus b over x plus 2. Remember, we factored that denominator x squared plus 2x. When we pull out the greatest common factor, we have x times x plus 2. Now, we need to try to solve this. Now, there are a lot of different type of cases for these, but we're going to look at this particular case. We have 3x plus 2. Now, when we multiply by the common denominator, ax squared plus 2x, what we're going to get, or in this case, you can cross multiply, that's a times x plus 2 plus b times x. Now what we want to do, we want to find the zeros. Now in this particular problem, what will give us a 0 here? That should be x is equal to 0. So we're going to go 3 times 0 plus 2 is equal to a times 0 plus 2 plus b times 0. On the left side, 3 times 0 plus 2 is 2, which is equal to 2a. So of course 1 is equal to a. Now on this other side, this denominator x plus 2, what will give us the zeros in this case? X is equal to negative 2. Alright, so we have 3 times negative 2 plus 2 is equal to a negative 2 plus 2 plus b times negative 2. On this left side, we have 3 times negative 2, negative 6 plus 4 is equal to negative 2b. So 2 is equal to b, and then that's what we have. So now this problem is not over. Now, if you remember, we broke this up for a reason. We broke this up into the integral of a over x plus b over x plus 2. So we have to go back to this. Now, a is going to be equal to what? 1 over x. And b is going to be equal to 2 over x plus 2. And of course, when we remember our rules for integration that we learned in Calculus 1, the antiderivative of 1 over x is natural log of x. And this is going to be 2 times the natural log of x plus 2 plus c. Now, there are other ways to do this problem. This is just a simple problem, so we want to use the most straightforward way. And there are several different types of partial fractions, all right, which we'll look at in other examples. But for this type of problem, this is the most straightforward and efficient way to work this particular type of integral.